Good morning, students. Welcome to science class on the chapter light. Just recall what we had studied in the previous class. In the previous class, first we had studied image formation by a convex mirror. Okay, so initially we kept the object at infinite distance. Initially, we kept the object at infinite distance. This is principal focus, center of curvature, and this is convex mirror. You know, right? So we make one assumption. What always we will keep object at the left hand side of the mirror. Okay. So now first we place the object at infinite distance. Okay, and we have considered two rays parallel to principal axis. Okay. After reflection, the rays are diverges like this. Okay. So if we extend these two lines, both are virtually connected or meet at F. Okay. So here position of the object, here position of the object at infinity, then the position of the image at the principal focus. Okay. So what about size? Size is highly diminished and it is point sized. Then nature of the image. Nature of the image is virtual and erect. Okay. Uh, because here why it is virtual erect means here we won't get the real image. When you place the screen over here or here or here, you won't get the real image. Why? Because after reflection, the reflected rays are not meeting. Okay, the rays are diverging. So that's why here we won't get real image. Okay, so next we kept the object between infinite distance and pole of the mirror. We kept the object between infinite distance and pole of the mirror. Okay. So also we are considering the parallel to principal axis. Reflection. Okay. And I console one more line which passes to pole of the mirror. Okay. Yes. So now see both the rays are virtually meeting at this point. Okay. So at this position we will get the image and that image is virtual. Okay. Because these two rays are virtually connecting between P and F. So now position of the object is between infinity and pole of the mirror. Then position of the image is between pole of the mirror and principal focus. Then what about size of the object? Just compare this one and this one. Okay, so now this is small, right? So that's why size of the image is diminished. And what about nature? Okay, see now this is the virtual image, right? Okay, so that's why the nature of the image is virtual and erect. Okay, next see here if you keep object here or here or here or here or here, you will get the image between P and F only. But when you keep the object at infinite distance, at that time you get the image at the F. Okay, so here you won't get image between F and C or at the C. Okay, uh, so later now we will discuss convention, sign convention for spherical mirrors. Okay, so first one. This is very important while solving problems. See, okay. So first, just imagine I will keep the object here, and I will get the image here. Okay. So now, see here we will follow the sign convention rule according to our Cartesian coordinate system. This is positive y, negative y, positive x-axis minus x, and this is the okay. So now in the here this point pole of the mirror is we will consider as the origin. Okay. Next, suppose how to take see now the distance from object to pole of the mirror we call it as object distance. So now here while writing, we have to write that object distance in negative. Why? Because see here, now this is the left hand side. Okay? So means this axis minus x axis. So now here we should take this value with respect to this minus x axis. Down here all the values are negative, right? So that's why while writing v value we should write in negative. Okay. Next. Uh, mm, the distance between image, now this is the image, okay, the distance between image to pole of the mirror, how to write image. So now because this is also left hand side, right, so now we should compare this one with respect to this axis. So in this axis all the values are negative only, so that's why we should write the v values also negative. Okay. Next one, what about height of the image? See here we use small h, we use small h to represent height of the object. Okay. So now we use small h uh, to represent height of the object. So now how to write the height of the object? We should write in a positive or negative. Okay. So now how to compare this height? So now we should compare this height with respect to this axis, that is y axis. Okay. We should compare the height of this object with respect to this axis. So now they see in this axis all the values are positive, right? So that's why while writing height of the image we should write in positive. Okay. Next, height of the image. Okay. So now this is the height of the image. So now we should compare this height with respect to this minus y axis. Okay. We should compare height of this image with respect to this axis. Okay. And here we use h dash, small h dash to represent height of the image. Okay. So here we use h dash to represent the height of the image. So now if the image, so now the image position is between C and F. So at that time we should write h dash values in negative. And what about focal length? See, focal length for already I told, right? Focal length for convex mirror is always negative. Sorry, concave mirror. Concave mirror. See, the focal length for concave mirror is that is always negative. Suppose when you keep the object between F and P, when you keep the object between F and P, at that time you will get the image here, right? So that is right side of the mirror. So now here, see, now how to write object distance? So so same, we write object distance in negative. Then what about image distance? Okay, so now we'll take this distance with respect to this positive x-axis, right? So that's why in this case, write v value positive, not negative. Okay. Next, what about height of the object? Yes, we should compare this height with respect to this one, right? So that's why we should write the object height in positive. Next, what about height of the image? Okay, earlier, see, when you get the image between C and F, at this time you should compare this height with respect to this minus y axis. Now this see, now the object position is right side of the mirror. Okay, so now we should compare this height with respect to this positive y axis. Okay. So now here in this case we should write h dash value in positive. Okay. Suppose if you get an image at F or between C and F or at C or behind C. Okay. In all the cases we should write v value negative and h dash value negative. Suppose when you get the image that is the right side of or behind the mirror, at that time we should write v minus positive and h dash value positive. Okay. And observe here. So we have studied the image formation in the concave mirror. Okay. Suppose if the image is real, if the image is real, okay, at that time we will get the image right side of the mirror, right? Okay, if the image is real, then we should get that image below this principal axis, that is at F or between C and F or at C or behind C or at infinity. Okay, in these positions only we will get the real image. Okay, we won't get real image behind the mirror. If we get the image here, then we call that image virtual and erect. Okay, so if the image is real, then you should get the image at F or between C and F or at C or behind C or at infinity. So that's why while solving problems they will mention what the image is real and calculate the position of the image. At that time you should get V value in negative only. Why? Because if the image is negative, then the position of the image always it should be negative. Okay, clear? Suppose if the image is virtual, then you should get positive. Okay, so keep in your mind, if they will mention what the image is real and calculate the image distance, at that time you should get that answer in negative value. Okay, if you get the in positive, then it is wrong. Okay, see now this is in mirrors only. Okay, we'll see later what about in lenses. Okay, next book, the sign convention in convex mirror. Convex mirror. Okay, convex mirror. Okay, so just a minute, this is the position of the object and this is the position of the image. Okay, here also same. Okay, always we keep the object at the left hand side, right? So then we should take view negative and height of the image, that is positive. Okay, these two never changes. Okay, these two are remains the same even for mirrors and lenses. Okay, these two values always we should represent u value negative and h value positive. Okay, next, and your focal length of the convex mirror is, that is positive. Okay, next, what about to be, the images are formed by a convex mirror are always virtual and erect. Here you won't get real images. Okay, in the convex mirror, always every time you will get only virtual images. So that if the image is real, then we should get the V value for negative, right? Okay, I'm talking mirrors only. Okay, if the image is real, then we should get V value negative. So now the images are formed by a convex mirror are always virtual and erect. So if while solving problems, if they mention what the mirror is convex, at that time always you should get V value in positively. Okay. Next, what about H dash? See, if the image is virtual, then we get the image here only. Okay, so now we should compare this height with respect to positive y-axis. So in this case, height of the image should represent. We should write in positive values. Okay, so here for convex mirror, we won't get values in negative for position of the image and height of the image. Okay, yes. So next move to magnification. And today we discuss one important formula, right? So that is 1 by f is equals to 1 by u plus 1 by v. Okay, so we call this is a mirror formula. Here f represents the focal length of the mirror and u represents the object distance and v represents the image distance. Okay, next move to magnification. See, magnification means it is the ratio between height of the image to the height of the object. Okay, so that is m is equals to h dash divided by h. H dash means what? Height of the image. Then h means height of the object. Then what is the magnification? Magnification means it is the ratio between height of the image to the height of the object. Then what is the meaning? See here, just compare the height of the image with respect to height of the object. Okay, for example, if height of the image is 2 centimeter, then so height of the object is 2 centimeter, then height of the image is 4 centimeter. So now can I say, see here, just we are comparing the how many times image is greater or smaller than the object. Okay, now here I can say, so now the image is 2 times greater or bigger than the object. Okay, so clear, right? What is magnification? Magnification means it's just we are comparing height of the image with respect to the height of the object. How many times it is greater or smaller? Okay. Magnification. So magnification means it is the ratio between height of the image to the height of the object. Okay. So now we can let this m. Also we can calculate magnification by using this formula also. Like, okay. Yeah, that is m equal to minus v by u. Or here it is the ratio between image distance to the object distance. Okay, see, these three formulas are very important while solving the problems. Okay, height of the object is 2 centimeter, then height of the image is 4 centimeter, right? Here we can clearly say that the image is 2 times greater than the object. So instead of that one, here we can say that the image is 2 times magnified. Okay, the image is 2 times magnified, which means the height of the image is 2 times greater than the height of the object. Okay, so we call it magnification. Okay, yes. Okay, I think the reflection part is completed. So now only the remaining is problems. Okay, so now to discuss some problems. See, before that, we should know these three formulas right here. 1 by f equal to 1 by v plus 1 by u. Okay, then second one for magnification, m equal to h dash by h. Then we have one more formula, minus v by u. See here, so here m equal to h dash by h, then m equal to minus v by u. So now can I write all this equation as 1 and this equation as 2? By combining 1 and 2, so we can write h dash by h is equals to minus v by u. Okay, see, these formulas are very important for solving the problems. Okay. So first I'll write a simple problem. Find the focal length of a convex mirror whose radius of curvature whose radius of curvature is 32 centimeter. Okay. Yes. Here, very simple question. Find the focal length of a convex mirror whose radius of curvature is 32 centimeter. First here, which mirror? No, the mirror is convex mirror. Okay. So now how to find out the focal length? Here, so what is this radius of curvature? So we can write R is equals to 32 centimeter. Okay. Then how to calculate the focal length? You know, in the previous time you studied, right? This relation R is equals to 2f. Okay. So now we need focal length, right? Then bring to this side. That is R by 2 is equals to f. Or we can write f is equals to R by 2. Then substitute the values. What is the radius of curvature? Radius of the curvature is 32 centimeter divided by 2. Okay. Yes. What is the answer? That is 2 ones are. This is 260. That is 16 centimeter. Okay. And here see the focal length of the convex mirror is always we should get in positive, right? So that's why we should write focal length equal to 16 centimeter. If it is concave lens, then we should write radius of curvature minus 32. Okay, because the radius of focal length of the concave mirror, which the radius focal length of the concave mirror always is in negative, right? So that's why while writing radius of curvature for concave mirror, we should write R equal to minus 32 centimeter. See, this is for concave mirror, not convex mirror. Here we should write R equal to plus 32. Why? Because the focal length of a convex mirror always we should write it positive, right? So that's why f equal to plus 16 centimeter. Okay. Yes, very simple one. So next question. Second question. A convex mirror. A convex mirror used. Convex mirror used clear mirror. On an automobile. Has a radius of curvature of 3 meter. To stop. Plus if a bus is located at 5 meter from this mirror, find the position nature, nature, and size of image. Size of the image. Okay. Yes. See here. First, convex mirror used for rear view on an auto has a radius of curvature of 3 meter. Okay, so there's radius of curvature of 3 meter. 3 meter. If a bus is located at 5 meter from this mirror, okay, if a bus is located at 5 meter from this mirror, find the position, nature, and size of the image. Okay. So first, friend, what are the data given? Okay. See what is this radius of first observe which mirror it is. So now here this is convex mirror. Okay. If the mirror is convex, then we should think what the images are formed by a convex mirror always virtual and erect. First, right, radius of the curvature. Okay. R is equals to 3 meter. Okay, see here we should write a positive because it is a convex mirror. If it is concave mirror, then we should write R value. R value is equals to minus 3 meter. Okay. Next, if a bus is located at 5 meter from this mirror, what is the meaning? If a bus is located at 5 meter from this mirror, okay, so which means here the bus which is 5 meter distance from the mirror, that is u is equals to minus 5 meter. Okay, so here if a bus is located at 5 meter from this mirror, which means the distance between object and mirror, here object, so here bus is the object, right? So that is the distance between bus and the mirror, the distance is 5 meter, and here we should write u is equals to minus 5 centimeter. Why? Because according to our graph, right? So now see, always we will keep that object at the left hand side, which means minus x. We should compare that object distance with respect to minus x axis. Okay, so that's why u is equals to minus 5 meter. Next, find the position, nature, and size of the image. Okay, so here we need then size of the image, that is dash and nature. Then nature. Okay, so we know the formula. What is the formula? See here, this formula which gives the relation between focal length, position of the image, then position of the object. Okay, so now so we can go with this formula, but here we don't know focal length, right? Here we know the u value. Our work is to find out our work is to find out v, which means position of the image or image distance. But we should know y, right? But we don't know how to solve. Just observe here. Now this r is what? Radius of curvature. So r is equals to 3 meter. But we know on relation what r is equals to 2f, right? So here we know the r value. So we can find out the focal length, right? Yes. Substitute the value. R equal to 3. Okay. R equal to 3 to f. So now we can write this as 3 by bring to this side. Okay, that is 3 by 2 is equals to f, or we can write f is equals to 3 by 2. Okay, what is the answer? Then f is equals to 1.5 meter. Okay, so now the focal length of a convex mirror is 1.5 meter. Okay. So better you can write this one. I give you just 2 minutes time. Okay, write fast. So here focal length of the convex mirror is 1.5 meter. Okay. Okay. Yes. Now I will erase this one. Okay. So I will write here F is equals to 1.5 meter. Okay. Next. So find out V. So you know the formula. 1 by F is equals to 1 by V plus 1 by U. Okay, so here we need 1 by V, right? So bring 1 by U this side. That is 1 by F minus 1 by U equal to 1 by V. So here it is first, right? What happens when you bring to from left hand right hand side to left hand side? So the sign changes, that is minus. Okay, next we can write this as 1 by V equal to 1 by F minus 1 U. Okay, yes, now substitute the values. So 1 by V is equals to focal length is 1.5. 1.5. Then minus what is the value of U? That is minus 5. Minus 5. Okay. Next. So 1 by V equal to 1 by 1.5, and here minus by minus, that is plus. So 1 by 5. Yes. What is the next step? So now here we should take the LCM of 1.5 and 5. So take the LCM. Okay. 1 by V. Take the LCM of 1.5 and 5. Yes. What is the LCM of 1.5 and 5? That is 7.5. 7.5. The LCM of 1.5 and 5. Okay. Hope you know how to take LCM 1.5 and 5. Next. So then multiply here 5. Okay. So that is 5 plus here you have to multiply 1.5. That is 1.5. Okay. Right fast. Okay. Yes. So now I will use this one. So now 1 by V equal to, see, 5 plus 1.5, that is 6.5 divided by 7.5. See, now this is 1 by V. We need V, right? Okay. So we can write this as V is equals to 7.5 divided by 6.5. Okay. Yes. So now how to divide this is 7.5 divided by 6.5. So better multiply 10 and divided by 10. Okay. So then we will get V is equals to 75 divided by 65. Yes. Let's do it. Now I will use this one. I write the answer directly. Okay. So here we will get V is equals to 1.15 meter. Okay. So here V is equals to 1.15 meter. Okay. See here, just observe here. Now the V value is positive, and V equal to positive 1.15. Okay. Why? Because the images are formed by a convex mirror are always virtual and erect. If the image is virtual, then we should get v value in positive. Okay, so that's why we got v equal to plus 1.15 meter. Okay, next. So next now is calculate h dash. Okay, to calculate h dash, we have this formula. Okay, so m is equals to h dash by h. See here, if you use this one, you should know m and h value. Okay, but here we don't write m and h value. Okay, how to find out? So now, so here we can't use this one. Okay, to calculate the h dash, so first find out the magnification. Okay, so we can go with m equal to minus v by u. Why? Because we know the v value and u value. Okay, do it. So I use this one. Now magnification m is equals to minus v by u. Okay. So now v value is, so shall the value is v value is minus 1.15 divided by u value is minus 5. Okay. Okay, so minus 5 minus plus, that is 1.15 divided by 5. Okay, so better into 100 then divided by 100. Okay, so then we get m is equals to 150 divided by 500. So here directly m is equals to 0.23. 0.23. So now magnification is m equal to 0.3, which means, see here. So now we can say that it is 0.23 times magnified, which means the size of the image is less than the, sorry, height of the image is less than the height of the object. Okay, so now second question, we need size of the image, right? Yes, we need h dash. Okay, edit this one. Yes. Next, calculate the size of the image. Oh, sorry, here one small mistake. Position nature, not size of the image, magnification of the image. Okay, magnification of the image. Magnification of the image. See, in your NCERT textbook, it is misprinted. Okay, just correct it. Example 10.1. Last statement: find the position, nature, and size of the image. It's not the size of the image; it's a magnification of the image. Okay, because we can't find out h dash, because here we don't know h value. Okay, here we don't know h value, so that's why we can't find the h dash value, so that is we need magnification. Okay, so magnification is that is 0.23. Okay, yes. So here what is the nature of the image? The nature of the image is, it is virtual and erect. Why? Because it is a convex mirror, and we got a v value as that is plus 1.15 meter. Okay, so now this is, it is in first right, so that's why the image is virtual and erect. Okay. Okay, I'm once again saying here in your answer textbook, example 10.1, it's not size of the image. Okay, just do the correction. Yes. Next, move to second question, third question. An object 4 centimeter in 4 centimeter 4 centimeter in size is placed at 25 centimeter 25 centimeter in front of a in front of in front of a concave mirror of focal length of focal length 15 centimeter meter at 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 what distance from the mirror at what distance from the mirror should a screen be placed in order in order to obtain a sharp image in order to obtain a sharp image. Find the find the nature and the size of the image. Size of the image. Okay. Yes, here lengthy problem. Okay, an object 4 centimeter in size is placed at a 25 centimeter in front of a concave mirror of focal length 15 centimeter. Okay, at what distance from the mirror should a screen be placed in order to obtain a sharp image. In order to obtain a sharp image, find the nature and the size of the image. Okay, first let the given data. What are the data given here? An object 4 centimeter in size, which means object distance, sorry, object height, that is h equal to 4 centimeter. H is equals to 4 centimeter. Then and is placed an object, okay, portion is placed at 25 centimeter in front of a concave mirror. Means here the distance between mirror and the object, okay, that distance is 25 centimeter. That is u is equals to here we should write minus, okay, minus 25 centimeter. Okay, next in front of a concave mirror of focal length 15 centimeter. And here which mirror? This one. This is concave mirror. So that's why we should write f value, that is focal length is equals to minus 15 centimeter. Minus 15 centimeter. Next, at what distance from the mirror should a screen be placed in order to obtain a sharp image? What is the meaning of this statement? Simple. Here we need position of the image or image distance. Here we need v. Okay. Then find the nature and size of the image. Size of the image, that is h dash. Okay. Clear? So here the data h given, that is h equal to 4 centimeter, u is equals to minus 25 centimeter, then focal length f is equals to minus 15 centimeter. Okay, so here we need position of the image, that is v, and size of the image, that is h dash, and finally nature of the image. Okay, so now I will erase this one, okay, to get a space. So now I will write here, okay, the data here, that is h equal to 4 centimeter, then u is equals to minus 25 centimeter, then focal length is minus 15 centimeter, and here we need v, h dash, then nature. Okay, yes. So first thing, so calculate the image distance. Okay, for that we have formula, that is 1 by f equal to 1 by v plus 1 by u. We need v, right? So bring 1 by u this side, that is 1 by f minus 1 by u equal to 1 by v, or we can write 1 by v equal to 1 by f minus 1 by u. Okay, so select the value. F value, that is minus 15, then this is minus divided by minus 25. Okay, next plus or minus, that is 1 by 15, and minus by minus plus, that is 1 by 25. So now take the LCM, 59, 25. Here, yes, 1 by b, the LCM of 15, 25, sorry, 15, 25 is, that is 75. Okay, yes. Next, so multiply here 5 and here 3. So it is minus 5 and here is plus 3. Okay, so 1 by b equal to minus 5 plus 3, that is minus 2 divided by 75. So here we need, right? And here we need period. notation is 2. That is V equal to minus 75 divided by 2. Okay. Yes, find the answer. 75 divided by 2. So here we get V equal to minus 37.5 centimeter. Okay. See, observe here. Here we got V value positive. So clearly we can say that nature of the image is virtual. Sorry, nature of the image is real and inverted. Okay. Yes. So next step. So V equal to minus 37.5 centimeter. Then what about H dash? Okay, we need H dash, right? So we need this one. To calculate H dash, see we have this formula m equal to H dash by H, but here we don't know magnification. Okay, so now combine these two because here we know H value, V value, and U value. So combine these two, so we'll get this equation, right? H dash by H equal to minus V by U. Why? Because here we know H value, V value, and U value. Okay, so now H dash by H dash, better write this. H dash by H and m equal to minus V by U. All this equation 1 and 2 combining 1 and 2 will get H dash by H equal to minus V by U. Now substitute, take H that side. So that is H dash equal to minus V by U into H. Substitute the values. Is H dash equal to V value minus 37.5 divided by U value minus 25 into H value, it is 4 centimeter. Okay, it is this one. Okay, so H dash equal to, see, minus into minus, that is plus 37.5 divided by minus 25 into 4. Then plus or minus, that is H dash equal to 37.5 divided by minus 25 into 4. Okay, so that area into 10 then divided by 10. So then you will get minus 375 divided by 250 into 4. Just simplify this one and write the direct answer, that is H dash equal to, finally you will get H dash equal to minus 6 centimeter. Okay. So here H dash is minus 6 centimeter. Okay. See here, now position of the object, sorry, height of the image is 4 centimeter, height of the object is 4 centimeter, then height of the object, height of the image, that is minus 6 centimeter. Okay, so clearly here we can say that the image is magnified here, or the height of the image is greater than the height of the object. Okay, then what is the nature? You know, here we got V value negative, right? So if the V value, if it is in negative, then what is the meaning? That the image is real and inverted. Okay. Yes. So I will stop here. Tomorrow we continue the class.